Hi, my name is Kumiko Usuda-Sato from National Astronomical Observatory of Japan, NAOJ. Thank you very much for watching my presentation. In my talk, I would like to share my experiences about how to make a conference inclusive through the IAU, International Astronomical Union Symposium. To the right, you see the original name tag of the symposium, and I will explain it later. In my slides, I use a recommended color combination, considering people with color deficiency. This is a table of recommended color combination by Color Universal Design Organization, Japan. I use the recommended colors for the display, written in blue numbers, such as 255750. This is yellowish red instead of very red. And I also use yellowish blue. Also, I use large Gothic or sans serif letters, considering low vision people who are hard to see letters. From the beginning, please think about the following situation. You are a professional astronomer and give a lecture at a university. In your lecture at a university or in your public talk, you want to explain the 8 planets in the solar system and their relative sizes. A visually impaired student signed up to your lecture. How do you explain the planets and their sizes? Have you ever experienced a similar situation? You may have seen this kind of image of the sun on the left and 8 planets. The sun is a star and much bigger than the planets. You also explain the inner rocky planets like Mercury, Venus, Earth, and Mars are smaller than gas giants like Jupiter and Saturn. But visually impaired student cannot see the image. How do you explain it? Some teaching resources already exist inside and outside of Japan. The first one is tactile images of celestial bodies. You see Jupiter's image on the left and its tactile image on the right. The tactile image was developed using dots of 3 different sizes. On a paper, the dots are raised up, and when you touch the image, you can understand Jupiter's outline, stripes of clouds, and the great red spot, a giant star of Jupiter. Astronomers simplified the visual image of Jupiter to develop the tactile image in collaboration with visually impaired people. The tactile images are published as a multimodal astronomy textbook entitled The Universe and Us, written by Professor Shin Mineshige at Kyoto University and Jun Takahashi, high school teacher of Earth Science. Multimodal means the same contents were published in multiple media, such as printed version, braille version, audiobook, and ebook on PC. Another solution is to use plain balls to show relative size of the planets. Universe Awareness at Leiden University, Netherlands, developed a set of teaching materials called Universe in a Box. In the box, you can find a set of the sun and the planet balls. When we held Touch the Universe special exhibition at Japan Braille Library in 2018, we put each planet ball in a Ziploc small bag and added a Braille label. You see the planet balls in the blue rectangle, and here is an enlarged photo. To the right, you see the Neptune ball. You recognize that these materials are also helpful for sighted people as well as visually impaired people to understand the celestial bodies. By considering people with special needs, we can develop resources and activities that are easily accessible to everyone. So, why diversity and inclusion are important in astronomy and other science fields? The first reason is human rights. Everybody has a right to discover and learn about the universe, and nobody should be cast aside or left behind. These words are originally from Professor Mineshige, and we published them on our Nature Astronomy comment. Actually, I am an astronomer and talk about astronomy and outer space. But the right to discover and learn is not limited to astronomy, of course. Another reason is the benefits for research. According to Powell's Nature paper, ethnic diversity strongly correlated with citation counts. A research team with diverse members can produce a good outcome. In addition, IAU set the 5 goals in its Decadal Strategic Plan 2020 to 2030. The goal 2 is the IAU promotes the inclusive advancement of the field of astronomy in every country. IAU recognizes the importance of inclusion. And let me share my thoughts about the benefits of astronomy for diversity and inclusion. Number 1, before I started working at NAOJ in Tokyo, Japan, I lived in Hawaii, United States for 15 years and did extensive outreach activities for the local community. I feel that presenting astronomy for the local children in English is similar to communicating astronomy with visually impaired people, in the sense of knowing different backgrounds and cultures. By considering people with special needs or different cultures and backgrounds, we can develop easy to understand presentations and teaching resources for everyone. Number 2, through activities of inclusion, sometimes I discover new things. In the lower left, you see the photo of 3D models of the Subaru telescope, NAOJ's Large Optical Infrared Telescope, located on Mauna Kea, Hawaii. When developing the models, I discover new structures of the telescope. The lower right image is the Hands in Stars press release by IAU. The IAU working group, Astronomy for Equity and Inclusion, collected astronomy words in sign languages in different countries. And I was in charge of collecting Japanese sign language words. Comparing the words in different countries, I aware similar points and different points. So the topic of this presentation is how to include diverse people in your lecture, conference, or collaboration. And today I will focus on a conference. You can consider gender balance, ethnicity, disabilities, and so on. I mean, other many minorities. We held the IU Symposium, Astronomy for Equity, Diversity, and Inclusion in 2019 at NAOJ headquarters, and I deeply involved in it as a LOC chair and a core team member with my colleagues. In the lower right, I show the core team members of the symposium. Before we held the IU Symposium, we had organized a series of symposia on universal design for astronomy education in 2010, 2013, and 2016. From the beginning, I deeply involved in them. In 2010, we knew each other and started developing a national community. In 2013, we started working together and spent a long time for dialogue. In 2016, we provided many workshops and also added international components. We received participants from other countries, mainly from Asia. This is how we developed the national community and expanded it to international community. In this sense, for me, IAU Symposium in 2019 is a natural extension from the Universal Design Symposia. At the Universal Design Symposia, we try to include diverse participants. This is a snapshot of an oral presentation in 2016. On the right side, you see the presenter. In the middle, you see the chairperson. She is blind. Sometimes people with disability led sessions. On the left, you see the Japanese Sign Language interpreter. On her back, you see real-time captioning with white sans-serif letters and black background. Considering non-Japanese speaking participants, we, the organizers, collected presentation slides and translated them before the symposium. You see the same slide in both Japanese and English. Here, I would like to share some tips about how to make your oral presentation inclusive. Number one, as I already presented, use large Gothic or sans-serif letters with recommended color combination. Number two, explain the details of image and graphs so that visually impaired people can understand. Look at the image published on the multimodal Introduction to Astronomy textbook. This is an infrared image taken by the Subaru telescope. Under the image, you see a long figure caption. Number three, try to avoid using this or that because visually impaired people do not understand. Instead, please use on the left, on the right, or in the direction of 1 o'clock. Number four, speak clearly and slowly. Like the long figure caption, I try to explain the image. Look at this image. In the middle, you see 4 bright newborn stars called trapezium. To the upper right of trapezium, you see finger-like or bird's wing structures. In the center of the structures, a massive protostar is hiding. The lower left of trapezium, you see a bright bar, like this. You can do it without any extra cost, and the detailed explanation can help not only visually impaired people, but also sighted people to understand well. In addition, providing an easy-to-understand presentation is beneficial for yourself. The IAU Symposium was held in November 2019 at the same location as the Universal Design Symposia. This is the very first IAU Symposium dedicated to astronomy for diversity and inclusion, and a total of 124 participants from 31 countries participated, including the IAU president. The room capacity is about 120 people. However, the expectations for this symposium from the international community were enormous, and we received nearly 240 applicants. Very unfortunately, nearly 120 people were waitlisted. If you are interested in, please read our brief report on the NAOJ website. You see the group photo for the symposium. The participants also had a shout out in their own language about inclusion and diversity, because the audio file is accessible to visually impaired participants.
1, 2, 3.
To make the conference room and bathroom accessible for everybody, we developed the tactile maps using PIAF tactile image maker manufactured by Hapro, a Polish company. When we copy the map on a heat-sensitive capsule paper and heat it with a PIAF machine, the black lines swell up. Look at the bathroom map on the left. The black lines and dots swell up, but the blue letters don't. Sighted people see the blue letters with the eyes, and visually impaired people read Braille by touching. At the conference room, we provided real-time captioning. Real-time captioning was helpful not only for hearing impaired people, but also non-native speakers of English. We also tried to provide free captioning using Google Docs voice typing, but we concluded that it does not work for the international community. For example, I have a Japanese accent, and many non-native speakers of English have their accents. It looks difficult for Google Docs to write down correct words. Some participants could not travel for mobility or financial reasons. Even before the COVID-19 pandemic, we accepted remote presentations. To make people in a wheelchair and guide dogs accessible, we kept the wide walkway and did not change the layout for all 4 days. In addition, we provided the Eventy application so that participants, including visually impaired people, could tell who was in the conference room. The poster room was assigned very close to the conference room, and everybody could switch the rooms very easily. We placed the poster panels, and people in a wheelchair could access to the posters. We also provided digital contents, and visually impaired people could read the posters with read aloud software. Considering the broader needs of participants, we provided additional rooms such as a prayer room, a quiet room, a breastfeeding room with NAOJ facility division support. We added Braille labels for all signs. We also created an original name tag to make smooth communication among participants. When I attended SciAccess conference for accessibility of science in 2019 at Ohio State University in the United States, I learned preferred gender pronouns, PGPs, and color communication. At our IAU symposium, we created posters about PGPs and color communication. Participants read the posters and put a label of PGPs as they liked on their name tags, such as traditional gendered pronouns like she, her, hers, or he, him, his, or gender-neutral pronouns like they, them, theirs, or they, her, her, or exact name instead of pronouns. Color communication was recommended by the Autistic Self-Advocacy Network in the United States. At our symposium, we combined the colors and shapes so that visually impaired people could touch the labels and understood. Green circle means, I prefer active communication. Please talk to me. Yellow triangle means, strangers and new people. Please do not talk to me. Red square means, please do not talk to me. In my talk, I presented how we made the IAU symposium inclusive. As I learned PGPs and color communication at SciAccess conference, and then imported them to our symposium. I hope participants of the IAU symposium use the similar ideas when they coordinate their own conferences. On the other hand, there are some challenges. Our efforts are time-consuming, and it is not clear to determine which supports are essential and which are not, in a limited budget and human power. Also, we concluded that the free Google Docs voice typing in English does not work for an international community, and we are looking for a low-cost captioning tool. This is my last slide. Sustainability and increasing awareness of these efforts and activities, and expansion of the inclusive community are the key factors. These efforts at a conference have just begun, but independent of the IAU symposium, let me present how I expanded my activities through Touch the Universe special exhibition. First, based on communications with visually impaired people, I recognize that developing a 3D tactile model is essential. Fortunately, I won the 4-year grant and developed tactile models of the Sparrow telescope with a 3D printer. When I presented them at a visually impaired group, I received very positive feedback, and a participant introduced me, the director of Japan Braille Library. Next, working with Japan Braille Library, I supervised the Touch the Universe special exhibition in 2018. The announcement of the exhibition reached to many museums and planetariums in Japan. Akashi Municipal Planetarium, located outside of Tokyo, contacted us, and Japan Braille Library and I helped them hold a similar exhibition in 2019. The group photo taken at Akashi Municipal Planetarium shows 2 planetarians, including the director of Akashi, a staff member of Japan Braille Library, and myself. Now, these 3 and 1 more organizations work together, and we have just won a grant to create a whole set of the Touch the Universe tactile exhibition. Other science museums and planetariums can borrow it and hold a similar exhibition very easily. This is how I expanded the community, increased awareness, and made my activities sustainable. To implement inclusive science, let's start from a small thing and show your efforts and activities to others. Then you can start collaboration, increase awareness, and expand the community. My talk is that's all. Thank you very much for listening.